based on the workflow and process, the role of AI modeling and Python programs. Pradeep K. Suri. Author, researcher, and AIDNN architect. Data for Python program. Process specification modeling. 1. Process 1, Process 2, Process 3, Process 4, Process N. 2. In each process, manpower cost. 3. In each process, M/C cost per hour. 4. In each process, M/C maintenance cost, M/C downtime reason. 5. In each process, M/C energy cost. 6. In each process, M/C job order, system generate. 7. In each process, raw material cost or use of any assembly. Objective, cost of each process and total cost versus budget cost in INR. Explanation of the workflow, process, and role of AI modeling and Python programming in cost analysis. Workflow and process breakdown. 1. Process 1, Process 2, Process N. These represent the individual steps or stages involved in production process. The specific number, N, will depend on the complexity of operation. It's crucial to clearly identify and define each process for accurate cost analysis. 2. Manpower cost. This refers to the labor costs associated with each process. It includes salaries, wages, and any benefits paid to employees directly involved in that specific step. You might need to consider factors like skill level, experience, and work hours to calculate the manpower cost accurately. 3. Machine cost per hour. This represents the hourly operational cost of the machinery or equipment used in each process. It could include leasing or ownership costs, depreciation, and any ongoing maintenance expenses. 4. Machine maintenance cost, M/C downtime reason. This captures the costs incurred when a machine malfunctions or requires scheduled maintenance. It's essential to track downtime reasons to identify areas for improvement and potentially reduce these costs. 5. Machine energy cost. This refers to the energy consumption, electricity, fuel, etc., associated with operating the machinery in each process. Understanding energy usage helps optimize processes and potentially reduce costs through energy-efficient practices. 6. Machine job order. This details the specific tasks or production runs assigned to each machine within a process. It provides crucial context for analyzing costs associated with different workflows or production volumes. 7. Raw material cost or assembly use. This captures the cost of the materials or components transformed or used in each process. This could be the cost of raw materials, subassemblies, or any other inputs required to complete the process. Role of AI modeling and Python programming. While breakdown provides a solid foundation, AI modeling and Python programming can significantly enhance cost analysis. 1. Data collection and automation. Python excels at automating data collection from various sources, such as machine logs, financial systems, and production records. This streamlines the process and ensures consistent data for analysis. 2. Predictive AI modeling. Machine learning algorithms built using Python can analyze historical data to predict future costs based on factors like production volume, material prices, energy consumption patterns, and machine maintenance needs. This enables proactive cost management and resource allocation. 3. Process optimization. AI models identify inefficiencies or opportunities for improvement within processes. Python is used to develop simulation models that test different scenarios and predict cost implications before implementation. 4. Scenario planning and cost forecasting. Python allows the creation of models that consider various factors, example economic fluctuations, material availability, and generate cost forecasts for different planning horizons. This helps in making informed business decisions. 5. Cost visualization. Python libraries like Matplotlib or Seaborn can create compelling visualizations of cost data. These visualizations can help you identify trends, outliers, and areas for cost reduction more easily. Integration with workflow. 1. Data integration. Align data collection efforts with workflow breakdown. Capture relevant data points for each process, manpower hours, machine uptime/downtime, energy usage, material consumption, etc. 2. Model development. Train machine learning algorithms in Python. Consider factors like production volume, material prices, energy consumption, and machine maintenance history for training the model. 3. Cost analysis tool development. Create a cost analysis tool using Python that takes existing workflow data and incorporates AI model predictions. This tool can provide cost estimates, identify cost drivers, and suggest potential areas for optimization. Overall benefits. By leveraging AI modeling and Python programming, you can gain a deeper understanding of production costs, predict future trends, optimize processes, and make data-driven decisions that ultimately lead to cost reductions and improved efficiency. #Python program result. Job order: no process manpower cost, machine cost per hour, machine maintenance cost, machine energy cost, raw material cost, total cost. Joe engine aircraft 10 process 194,348.00 5000 and 18.00 12,354.00 12,890.00 332,719.00 457,329.00. The table shows a breakdown of costs associated with 10 job orders for engine aircraft components. Each job order has a unique identifier, job order no, and is associated with a specific process. The table details various cost categories incurred for each job order. Manpower cost, the cost of labor involved in the job order. Machine cost per hour, the cost of using machines per hour for the job order. Machine maintenance cost, the cost of maintaining the machines used in the job order. Machine energy cost, the cost of energy consumed by the machines during the job order. Raw material cost, the cost of the raw materials used in the job order. Total cost, the sum of all the cost categories for each job order. By analyzing this table, you can gain insights into the cost structure of each job order and identify areas for potential cost optimization. For example, you can see that the raw material cost is the highest cost category for most job orders. This suggests that focusing on reducing raw material costs could have a significant impact on overall job order costs. Cost components related to job orders. 1. Job order. This refers to a specific production or manufacturing order. Each job order is uniquely identified by a number or code. It helps track and manage production tasks, resource allocation, and scheduling. 2. Process. The process describes the steps involved in producing a product or completing a service. It includes activities such as design, material procurement, assembly, quality control, and packaging. The process can vary based on the type of product or service being delivered. 3. Manpower cost. Manpower cost represents the expenses associated with labor or human resources. It includes wages, salaries, benefits, and other costs related to employees directly involved in the production process. Manpower costs can vary based on the number of workers, their skill levels, and the time spent on each job order. 4. Machine cost per hour. This cost factor accounts for the use of machinery or equipment during production. It includes expenses related to operating and maintaining machines. The cost per hour depends on factors such as machine type, depreciation, repair, and energy consumption. 5. Machine maintenance cost. Maintenance costs cover routine servicing, repairs, and upkeep of production machinery. Regular maintenance ensures optimal performance and extends the lifespan of equipment. These costs can vary based on the complexity of the machines and their usage. 6. Machine energy cost. Energy costs are associated with powering production machinery. This includes electricity, fuel, or any other energy source required for running machines. Efficient energy management can significantly impact overall production costs. 7. Raw material cost. Raw material cost refers to the expenses incurred for purchasing materials needed to create the final product. It includes the cost of raw materials like metals, plastics, fabrics, chemicals, etc. Efficient sourcing and inventory management are essential to control raw material costs. In summary, job orders involve a combination of labor, machinery, energy, and raw materials. Understanding these cost components helps businesses optimize resource allocation, improve efficiency, and make informed decisions. Thank you.